Good morning, one and all. Myself Jagadish RM, Assistant Professor, Department of CSC. So today I am going to discuss about the line coding technique. In the previous video, we have seen the line coding techniques such as unipolar NRZ, polar NRZ, polar NRZ-L, polar NRZ-I, and polar RZ. Next to in Polar, we have two more schemes. They are Manchester and differential Manchester line coding schemes. First, we will discuss about the Manchester line coding technique. The Manchester coding consists of combining the NRZL and RZ schemes. So already we have seen what is this NRZL. L means level and RZ return to zero schemes. So in this, every symbol has a level transition in the middle from high to low or low to high uses only two voltage levels. In this Manchester encoding, each bit period has both the high and low voltage values. If a data is a 1, the first half of the bit time period is sent at the positive level, and the second half of the period is at the negative level. For data bit of 0, first negative signal and then a positive signal. There is a transition which can be used for synchronization. Sometimes this method is called self-clocking encoding method. And also we will see about the differential Manchester. In this coding, it combines both NRZI and RZ. NRZI means non-return to zero inverted and return to zero schemes. Um, Here, in this differential Manchester, every symbol has a level transition in the middle, but the level at the beginning of the symbol is determined by the symbol value. One symbol causes a level change, the other does not. We will see in the example. So in this differential Manchester, a binary zero is marked by a transition at the beginning of an interval, whereas a one is marked by the absence of the transition. In the diagram, we will see that. In this encoding method, detecting changes is often more reliable, especially when there is a noise in the channel. This encoding scheme is a combination of RZ and NRZI. It also transmits at the middle of the bit, but changes phase only when one is encountered. So in the diagram, you can see. First, we will see the Manchester. Excuse me. Manchester scheme. In this, the input data is 010011. We can observe it is a combination of NRZL and the RZ. In NRZL, what we do usually, so whenever there is a zero, we take the positive voltage high, and whenever there is a low, we take negative voltage level. So since this is the combination of NRZL and the RZ, so whenever we go for the RZ, actually the transition will take place at the middle of the pulse, as we already seen in the RZ. So since this is the combination of NRZL and RZ, so it is taking the transition, it is starting from the positive level for the 0 bit, and it is taking the transition exactly in the middle. In RZ, what was happening? It is moving towards the 0, but in this, since this is the combination of both NRZL and RZ, it moves towards the negative voltage here. Whereas for the positive one, it starts with the negative voltage and it moves off of the voltage, then exactly in the middle it takes the transition, and it moves towards the positive voltage. Since the next bit is 0, it starts with the positive voltage, it moves exactly half of the pulse and takes the transition. It moves towards the negative voltage. Once again, there is a 0, so it should start from the positive voltage and it should take the transition in the middle of the pulse and it should move towards the negative voltage. Then next bit is 1, so it should start with the negative voltage and it should take the transition in the middle of the pulse and it should move towards the positive voltage. Since the next bit is also 1, so it should start from the negative voltage, it should take the transition in the middle of the pulse and it should move towards the positive voltage. So this is about the Manchester encoding scheme. Whereas next we have the differential Manchester encoding. As I told already, differential Manchester encoding is the combination of RZ and the NRZI. It also transits at the middle of the bit, but the changes phase only when one is encountered. You will see the thing. Since the first bit is 0, so this is differential Manchester, so it should start from the negative voltage and it should take the transition in the middle of the pulse and it should move towards the positive voltage. So what is the meaning of the empty bubble? The empty bubble meaning is no inversion, next bit is 1. When next bit is 1, no inversion here. Actually what happens, it will start from the positive voltage and it will take the transition in the middle of the pulse and it should move towards the negative. So whenever the next bit is 0, it takes the transition. You can observe it is not starting from here, instead it is moving towards the positive pulse and it is taking the transition. Clear? So this is what the thing. So next, once again, next bit is what? 0. So it is taking the transition towards the positive voltage and it is starting from the here and it is moving towards here. So next bit is 1. So it should take the inversion of the previous one. So previous one is what? Whenever there is a 1, uh, uh, sequential ones, consequently if one appears, it should take the transition as we have seen already in the another time. So here this positive one, sorry 1, bit 1 is started from the positive voltage, it is moving towards the negative voltage by taking the transition, whereas here next bit is next one bit 1 should be exactly inversion of the previous one. It is starting from the positive level, whereas it is starting from the negative level. Here it is taking the transition at the middle of the pulse and it is moving towards the positive voltage. Since the previous one has started from the negative voltage, so next one should start from the positive voltage because it should take the transition. So it is moving here. So in this way, Manchester is the combination of NRZL and the RZ, whereas differential Manchester is the combination of NRZI and the RZ scheme. And in the diagram you can observe it requires more bandwidth. We will discuss in the next point. In Manchester and differential Manchester encoding, the transition at the middle of the bit is used for synchronization. You can observe here to achieve the proper synchronization, the transition is taking place in the middle of the bit. The minimum bandwidth of the Manchester and differential Manchester is 2 times that of NRZ. More bandwidth is required. There is no DC component and no baseline wandering. Already we discussed what is DC component, what is baseline wandering, and none of these codes has error detection capability. So this completes the polar Manchester and the differential Manchester. Next, we will go for the bipolar. As we have discussed already, there are um, three line coding: polar, unipolar NRZ scheme, then polar NRZL, NRZI, polar RZ, polar Manchester, polar differential Manchester. Five things are there in the polar. Whereas in the bipolar, next thing is bipolar. So in the bipolar we have AMI and the pseudoternary. AMI means alternate bit mark, alternate mark inversion, and we will see one by one. So in this bipolar, code uses three voltage levels, that is negative, positive, and zero, to represent the symbols. Note not transition to zero as in RZ. We've seen the example. Voltage level for one symbol is at zero, and the other alternates between plus and minus. We'll see the example. Bipolar uh, AMI, alternate mark inversion. The zero symbol is represented by zero voltage, and the one symbol alternates between positive and negative. We'll see the example. Pseudo ternary is the reverse of AMI, exactly reverse of the AMI. What is this AMI and pseudo ternary? We will see. Um, Alternate mark inversion, a neutral zero voltage represents binary zero. Binary ones are represented by alternating positive and negatives. Pseudo ternary, bit 1 is encoded as zero voltage and bit 0 is encoded as alternating positive and negative voltage. That is opposite of AMI scheme. So we'll see in the example. You can observe um, we have the input data bit 0 1 0 0 1 0. Whereas AMI alternate mark inversion, whenever there is a 0 bit, it takes the 0 voltage, whereas whenever there is a 1, it will take the positive voltage, and whenever there is a 0, it is 0 voltage. You can see in the diagram, and whenever the 1 appears, it will change positive to negative, negative to positive. See here, it should take the inversion of the previous one bit. Previous one bit has taken the positive voltage here. Next bit 1 is taking negative voltage. Suppose in the next upcoming, if 1 occurs, it will take the positive voltage. So this is about the alternate mark inversion. The name itself says alternative mark inversion. Whenever there is a 1, alternatively it will take the positive voltage and negative voltage, vice versa. Next is pseudo-ternary. So pseudo-ternary is exactly opposite of the AMI scheme. Whenever there is a 0, it will take the either positive or negative. In this 0 is the first one, it will take the positive voltage. And whenever there is a 1, it will take the 0 voltage. You can observe it is exactly opposite to the AMI. Whereas whenever there is a 0, if previous 0 is positive voltage and next 0 will take the negative voltage. So next 0 is what? Exactly opposite of the previous 0. This 0 is positive voltage and this will become this is the negative voltage and this will become the positive voltage. Whereas next one is the positive 0 voltage, and next 0 is also opposite of the previous 0. Previous 0 is what? Positive voltage, and next 0 is what? Negative voltage. In this way, this particular AMI and pseudo ternary bipolar schemes will work. So you can observe in the diagram, it requires once again more bandwidth. Okay, we will discuss. It is better alternative to NRZ disease, bipolar, AMI, and pseudo-ternary are the alternatives for NRZ. Has no DC component or baseline wandering, has no self-illumination because long runs of zeros results in no signal transmission, and it has no error detection capability. Yeah. So this ends the um, line coding and different line coding schemes such as unipolar NRZ, polar NRZL, polar NRZI, polar RZ, polar uh, Manchester, polar, differential Manchester, and also we discussed about the bipolar. In bipolar, we have two categories: AM, I, alternate, mark inversion, and the next one is pseudo-ternary. So this and the line coding schemes. So kindly go through the video, understand, then immediately I will send the assignment for solving the uh, uh, Manchester, differential Manchester, EMI, and the pseudo-ternary schemes. So kindly go through and answer for the assignment. Thank you one and all.